Hey guys, welcome back to the shop. So today I want to give you an overview of my new night setup. So I've just been working on this because for years a buddy of mine has been doing a lot of night flying. I had these nav lights on my heli, which would be enough for a dusk flight, but not enough for a real night flight. He finally talked me into setting one up, and I'm glad I did because it's a lot of fun. I want to show you how I set it up on this Whiplash Gas 700 class heli. First up, simple stuff, just standard out of the box night blades. These are Rototech Auroras because when I could get available, they have the battery packs associated with them. You can just buy those anywhere. Heli Direct, anything heli, etc., etc. On the tail, also got Rototech night tail blades. There's a couple different brands out there right now. Rototech and Rail both make night blades, along with some others. And of course, they all come out of the same Funkey factory. One thing I didn't realize, the Rails were easier to find, but they have orange lights. And the Rototechs are red LEDs. The Rototech red ones are much brighter, from what Roger told me. So I had to switch those out. And if anybody wants orange ones, I might put them up for sale. They work, but they're dimmer. The orange ones you can really only see well when it's pitch black. The red ones work even at dusk. So that's high-level overview. Now, just having the blades is not enough for somebody like me to night fly because I don't get good orientation without being able to see the body. So I just blatantly copied the kind of equipment that my buddy was using on his and added some light strips to the rest of the heli with switching, and now that's what I'm going to take you through. So let me put the camera down, get a good angle so you can see. Okay, so here's the setup. So what I did is I got a bunch of LED strips, the various kinds. You can get these all over the place. They're on eBay. You get them from Hobby King. Turnigy makes them. My buddy used a lot of Turnigy strips. I got strips from Ready Made RC, and they come in a couple of different styles. So the most common style you'll see is this wheel. It's a LED strip, and they have these 3-inch sections that have a bunch of LEDs and these little solder tabs, and it's a self-adhesive backing, and you get these in all different colors. I got white, red, and green. I also got yellow, blue, purple, pink, and whatnot. So you just peel the backing off, and as you can see on the canopy, I have a bunch of strips attached in different orientations. The nice thing is you can cut these into sections, and they cut right. You'll see everywhere where there's a solder tab, there's a cut line, and they're labeled. So you can cut them at any length you want on those sections, and then you can just solder up wires to those solder tabs. Just use a little pencil tip soldering iron and some good quality solder. And what you'll see there is that's how I set it up on the canopy. You can see this is the end that was factory finished with some wires that I just wired up. I ran the strip, and then I ran 2 strips. So I just cut this one and soldered some wires that just attached to this other guy, so I could do all this. I could do all different configurations and not have to have one continuous string, because this stuff doesn't bend either, right? So that's one style. The other style of LEDs that I use with these COB strips, we'll see how this works. So these are a little bit smaller. They're thinner. They're much thinner, and they've got this like rubbery diffuser on them. And at the end of this video, I'll shut the lights off and light it up so you can see what that looks like. So the LEDs are just spread throughout these, and they got this rubbery diffuser, so it looks like, rather than a string of Christmas lights, just this continuous lit up strip, like a old style fluorescent tube, right? Which is really cool. These can also be soldered. The only thing is it's a much finer connection. There's also adhesive backed. When you peel the backing, you'll see every inch or so there's a cut line and tiny little soldering spots. I have cut and soldered a few of these. It's really fiddly. You need a good, very fine pencil tipped iron. And when you start soldering up, you're going to be convinced that you're just going to solder your plus and minus wires together. You won't if you're careful, but it is tricky. I used a mix of both in different colors, and what you can see on the canopy is I actually used the COB strip to outline the whole canopy in white, and then I put the individual big going down each side and along the top. And what I did is white along the top of the boom, white around the edges of the canopy and the top. And then on the left and right side, since I already had red and green navigation lights, I did a big green strip down the right side and a red strip down the left side, which I think is going to look pretty cool in the air, but we'll see. I mentioned that I have to see how the COB strip works out. What I mean by that is I'm not sure it's going to stand up to vibration as well as the traditional style, just because it's much, much finer. So the first flight will tell. All right. So canopy, I used an old canopy that's been crashed a few times. There's a lot of epoxy repairs on it. I have 2 canopies the same color. Kept my nice one for summer flying, thinking I might go back and forth. What we have yet to see about that. I wired up everything, and I just used servo connectors at the end of the strips to plug in to a junction box at the back of the heli. So at the back of the Whiplash, we have a tray that they provide for electronics, which I don't use right now because everything is up front. And what I did is I put a couple of distribution boxes that you can plug in for with different color connections. You see the green and the white. That's for 2 different voltage levels. So one of the things I discovered, Roger had warned me about this, but I realized as I went through this, is that the different colored LEDs are different brightness levels at the same voltage. I think it's more to do with the way our eye perceives the color than that they would actually measure differently if you had like lab instrumentation. But the deal is, if you say run them off of 8 volts, like straight off of a LiPo, the white is just about, it's visible. It's not super bright. Red is good. Green is freaking blinding. So what I needed to do was step the green down a bit and bump up the voltage for the white and the red to kind of balance them. Now these strips are 12 volt strips, but they will come on anywhere between 6 and 8. You might ask me, why didn't I just run them at 12? And you could do that, and at 12 volts they're pretty similar, but the problem is once you get to 12 volts, they're brighter than the lights on the rotor. And Roger suggested, and I agree with him, that we don't want the fuselage of the heli to blind out the rotor light. It seemed like round 2S LiPo 7-8 volts is good. What I did is I've already got regulated 7 volts on the helicopter because I use a LiFi pack and we have onboard generator, and that's a good voltage for the green. The red and the white need a little bit more, so I want to give them 8 volts. So since we've got the generator, what I did is I just ran a second lead. It's a little complicated, but I split this is the generator, and it's AC to DC converter, which then goes into a voltage regulator, and that steps down to 7 volts for the electronics. What I did is I just tapped in and ran a second line from the AC DC converter output to the back, where I just have a small little Castle BEC that's providing 8 volt. So basically the generator is giving me 2 power buses, a 7 volt bus and an 8 volt bus. 7 volt bus is running all the electronics, receiver, gyro, servos, and some of the lights, the green lights, and also the nav lights. The 8 volt bus is running the white and the red lights to bring them up. One thing you really want to do, if you run your lights, your LEDs, off of the power system on your heli and not like just a separate battery completely isolated, is protect yourself from a short. Because what could happen is if one of these LED strips shorts and it's connected to your main power, it's going to bring down everything. So the way Raja puts a resistor in the line just to limit the current flow. What I did is I just used a fuse. So there's a couple of spots where I have these 1 amp fuses. So that way if the light's short, the fuse will blow and it protects my generator and the onboard electronics, right? So I've got power feed from the receiver back here, and that's the green connections and goes to this bus. Power feed from the generator to the 8 volt BEC, and that's the white connections, feeds that. I'm also using on-off switches. So I have a couple of these cheap on-off switches. You can get these on Amazon. Maybe I'll put some links in this video too, to where you can find this stuff. These RC on-off switches, there's all different types, but basically what you do is you plug it into a channel and you get an easy switched out for running lights and stuff. It's also cool if you want to do lights on like RC cars and things like that. They have 2 different types. One that's just got a servo connector on each end. You plug it in and all it does is it turns on and off servo bus voltage. The other kind, which this style is it's like a relay. So it's got a servo connection to a channel on your radio, which is the on-off, and it's a relayed switch that's got power in and out. So I used one of these to control the 8-volt bus, and then one of the other style to control the other bus. So basically I not only have all these lights running from onboard power, but I can switch them on and off from the transmitter, and I'll show you guys that. All right, so here's all the wiring. I like to keep all the wires strapped down, heat shrunk, make sure to have vibration protection and everything. This is a plug for that 8-volt BEC, so I can unplug it. The theory is by having plugs there and also having plugs on the connections to the canopy that I could still fly this year round, take the lights off in the summer. Why I say that is we generally only do night flying in the winter here. When the sun comes down early in the summer, it doesn't really get dark enough until 10 o'clock at night, and the mosquitoes are nuts, so I would not bother, right? So theoretically in the summer, I could switch back to my other canopy, and I'm not going to take the lights off the boom, but I could have a separate boom and torque tube set up so I could just pop this one off and pop the summer boom on and just connect everything with all these connections and go back to regular blades when I've got my summer set up. Remains to be seen if I end up building another gas machine. I may keep this as a dedicated night flyer. This thing is 11 years old. Yeah, 11, 12 years old now. So I love this heli, but if Miniature comes out with a new gas machine, I may build that as my primary and have this guy go to the... so that's the setup there. I mentioned all the fuses. I mentioned the wiring. The nav lights is a setup I got years ago. I don't remember the name of the place I got it from because I know they're out of business. There's a little LED controller that sits strapped on down here. It runs off of servo voltage. The only thing that gives me that I don't have otherwise is you have flashers. So I've got the directionals and I've also got flashing for the top and the bottom. You don't really need to do that. I've had it on here for years, so I just left it. So I've got a combination of all that. Pretty much that's the setup. Like I said, most of these LED strips are self-adhesive, so you just stick them on wherever you want them. I would recommend at all the connection points to make sure you reinforce things for vibration, especially if you're on a gas or a nitro. You might be able to get away with just sticking them on and leaving them alone for electric. But on the gas machine, I put a dap of goop silicone glue at all those connections to basically create a strain relief for all those solder joints, so you don't lose things. You also see the fuse. It's just a simple fuse that I soldered in the line. Is also gooped on there. These connections are gooped on. So I try to vibration proof everything. And that's pretty much it. That's the setup. Up next, I am going to flip the lights, put on the canopy, and show you what it looks like. Okay, so here we go. Now I just want to quickly show you the setup. So I shut off the lights, I plugged everything in. The heli is turned on. I actually have it hooked up to the bench power supply right now, just so you'd see what it's like when it's running under regulated voltage in the air. The lights exactly like the brightness that they would be. So I've got the transmitter on and have my lights on a knob, and I go to the first position, which gives me nav lights. So now, as you can see, I've got the tail beacon, the top and bottom flashers, and red and green, the left and right nav lights. Now, when I go to full on the knob, I get the whole night lights on. And that's the effect. Got white down the top of the boom and around the outline of the canopy. Got red all the way down the boom. And there you can see the difference between the COB lights, which are that continuous strip, and the individual LED strips. Right. And once again, I mentioned the COB is the kind that we'll have to see how it handles vibration in the air. Come around the front, and you can see on this side we have the green, right? And that's why I mentioned that I'm running the white and the red at 8 volts and the green at 7, so they roughly appear to be the same brightness. When I ran the green at 8 they were blinding. So that's it. That's the night flying setup. Hopefully we'll get to test it out in the next couple weeks. Maybe catch some videos in the air of this along with Raja's setup, and you can check it out. So thanks for watching. Bye guys.